equal to 0, we will get x equal to plus minus 1. Let me take this equation is, let me trace that. This is symmetric about both the axes, about both the axes, simple, sorry, about both the axes. If I just describe this whole circle, equation of the circle, first thing, second, it will not pass through the origin. It will not pass through the origin. Pass through the origin. It will not pass through the origin. Will not pass through the origin because this constant 1 is independent constant term. If there is independent constant term, okay, then the curve will not pass through the origin. So this is not passing through the origin. Okay, so putting y equal to 0, we get x square equal to 1, imply that x equal to plus minus 1. That means the points, the curve will meet the x-axis at the points. So 1 0, 1 minus 1 0. At these 2 points, the curve will meet. So the curve will meet the x-axis, the axis of x at 1 0 and minus 1 0. Similarly, putting x equal to 0, y is equal to plus minus 1. Okay, so again it will also meet the y-axis at 0 minus 1 and 0 plus 1. That means this is the circle, equation of a circle. Okay, so the same points we can describe this. Let me draw the figure here, simple. This is simple figure. Not passing through the origin. This is 0 0 origin. Circle is this. Let me take here a point which is 1 0. Here it is minus 1 0. A dash point. This is B point here. 0 1, and this is B dash point. Let me take 0 and minus 1. Circle here. Equation is, this is equation of the circle. This radius 1 up to this point, all are 1 1. This is how we can draw the circle. So this was the standard equation of the circle. Doesn't matter. Okay. So the question is 6th. We are done. Let me take the next question, 7th. Now, what does question 7 say? Let me check it. Question 7. What does it say? Let me check it. 7th question now. Okay, it says trace the curve x equal to a cos phi, x equal to a cos phi, and y is equal to b sin phi, y equal to b sin phi. Now it says that it is equation of an ellipse. Let me check it. Okay, so converting this into Cartesian form. Question number 7th here. Trace the curve x equal to a cos phi, y equal to b sin phi. Now this is ellipse, it says. Now let me check this equation of the curve. Solution. So squaring and adding these two equations. Let us take here. Let me take. This is first equation and this is the second equation. Here x upon a, we have taken this x a divided by this equal to cos phi, and y upon b equal to sin phi. This, let me take the third equation and this is the fourth equation. Squaring third and fourth. Squaring third and fourth, and adding, squaring third and fourth and adding, we get, what do we get here? This is x upon a whole square plus y upon b whole square equal to sin square phi plus cos square phi, or cos square phi plus sin square phi, doesn't matter, equal to 1. This is equation of an ellipse. X upon a whole square plus y upon b whole square is equal to 1. This is equation of an ellipse. Okay, this is the standard equation of an ellipse. Standard equation of an ellipse. Okay, where a and b are not equal, but a may be greater or b minor or major axis, you can say. Again, if I take this y equal to 0, b put both are, let me describe this whole curve. Description is that this is equation is symmetric to both the axes. It is symmetric to both the axes. One thing. Second is, it will not pass through the origin. We know that what is the equation of an ellipse, we know. But if one had to describe this in detail, and this is the description which I am taking here. So this is not passing, this is symmetric about both the axes. Symmetric about both the axes. Okay, both the axes. It will not pass through the origin because this is constant term 1. Okay, constant term, independent constant term. So it will not pass through the origin. Second thing, putting y equal to 0, let me take. Putting y equal to 0, we get x square upon a square equal to 1, or x square equal to a square, or x equal to plus minus a. So it means the curve will meet the x-axis at a0 and and minus a0. It will meet the x-axis. So it will meet the x-axis. It will meet the x-axis at point a0 minus a0, and similarly y is equal to plus minus b by putting x equal to 0. After putting x equal to 0, y is also equal to plus minus b. What I'm doing? Y is equal to plus minus b. That means the curve will meet the y-axis at the point 0b and 0 minus b. So the curve will meet the y-axis as well as x-axis at these points here. A is greater than b. A is major axis and axis, major axis, y is minor axis, or vice versa. So the equation of the curve, this ellipse, can be drawn easily, that we know from geometry. So this is the equation of an ellipse. If I take a greater than b, this is elliptical circle. This is a0 point. This is minus a0. If I take this as a, this is a dash. This is b. The point is here 0b. Here it is 0 minus b. Let me take this as b dash. Origin OO. Okay. The center of the ellipse 0 0, and it may be focus here. That is another point. We will discuss this in geometrical. Geometry, when we discuss about coordinate geometry or three-dimensional geometry, that is the point of that. But here the description of the curve, tracing of the curve, we have to define here. So tracing of the curve of this kind is done in this way. So this is the equation of the ellipse which we have described. Simply we can describe this easily joining these 4 points. Okay, at this point x equal to 0, if I just open that equation, find out dy dx, and then you will find out that at this point this is x equal to 0 here. So it will be x equal to 0, that means y axis will be the tangent at this point. So here x equal to 0 means y-axis. The new y-axis will be the tangent here. Here x-axis will be tangent. But at this point y0. Y0 means at x-axis which is parallel to the original x-axis. So in the same way, we can describe this. This is x-axis, x-dash axis, y-axis, y-dash axis. Equation of the ellipse. This is how we have to describe it. Okay. Symmetric to both the axes, not passing through the origin, then putting y equal to 0 or x equal to 0. So this is the 7th question which we have done. Now let me talk about 8th question, next one. What does the next question say? Let me check it. Now question number 8. Question number 8 is of what kind? Question number 8 is, trace the curve x equal to t square, where x equal to t square and y is equal to t minus 1.3 t cube. Okay. T minus 1 upon 3 t cube. This is x equal to t square, y equal to t minus 1.3 t cube. Okay, let me eliminate the variable t here, the parameter t here. So solution. Again by using first method. Elimination of parameter method. That is elimination of parameter. Elimination of parameter method. So what do you mean by this here? Y is equal to, here we have t minus 1.3 t cube. Now if I take t common first, let me take 1 minus, this is 1 minus t cube. Sorry, t square now. I'm sorry. Now this is t square left over. This is y is equal to. Okay, now if I take 1.3 common also, this is 1.3 t, that means 3 minus t square. Now what we have to do, this is y is equal to here. Now squaring both the sides, this implies that y square is equal to, it is 1.9 t square. Now this is 3 minus t square whole square. It means t square is now can be replaced by x. Because of that we have squared this. We can obtain a circle equation of a curve in Cartesian form then. So this is 1.9 t square means x here, t square from this first equation. This is, let me take first, and this is second equation. So second equation we were solving, and from second we have substituted now first. It will be x square 1. So putting or this is from first. We are solving this. So this is 1.9 x, but t square is x. T square is x. This is 3 minus x whole square. So what do we obtain here? So this is nothing but 9y square is equal to x into 3 minus x whole square. Okay. So what do we get here? This is the equation of the, okay, this Cartesian equation. Now solving this equation by our own method. So if I put here x equal to either plus 3 or minus 3, this value will give us, more than 3. Okay, at x equal to 3 it is 0, y equal to 0. Alright, and so solving this equation, so equating coefficients of the smallest degree term, putting y equal to 0, so we will obtain the solution here. So, okay, so that is, let me find out the equation here. That means the question is this. Now, each question is of different kind of question here. Okay, so let me solve this here. That will give us certain kind of, okay, Let me replace the marker. I have to replace it. Okay, so here x equal to, now solving this equation. So this is Cartesian equation we have obtained. Finally, Cartesian equation we have obtained here is of this kind. Let me talk about this equation then. Is it a symmetric about x-axis because y square is even? So this is the Cartesian equation. So the Cartesian equation is, here is 9y square is equal to x into 3 minus x whole square. This is the Cartesian equation. So this is third equation let me take. Okay, now let me solve this or trace this. This Cartesian equation is to be traced now. Let me talk about this. Okay. Everything is becoming black. Okay, so now this equation is, first thing, let me describe this Cartesian equation. This will be symmetric about. This will be symmetric about x-axis. Why? Because y square is even number, even power. This will be symmetric about x-axis as y is even power. Powers of y even powered, x is not even power. This x is okay, it's different one. So even power. It will be symmetric about by x. Now it will pass through the origin. It will. Why? Because no constant independent term. Second point, it will pass through the origin. It will pass through the origin. Pass through the origin. Okay, has no independent term is there. So putting y equal to 0. So putting y equal to 0 in third we get, what do we get here? Okay, so y equal to 0 if I put, then x into 3 minus x whole square equal to 0. So x equal to 0 and x equal to 3. That means the equation is 0, 0 and y equal to 0 and 3, 0. These are the 2 points at which the x-axis or the curve will meet the x-axis. So at these 2 points, the curve will meet or will pass through the x-axis. Meet the x-axis. The origin, to the origin curve is passing. Second point is beyond 3, x equal to 3. Whether the curve is lying or not lying, let me talk about that also. Okay, because then negative, when it will be negative. Okay, if I put x equal to no, it's not, it is 0 only, but it's not infinity. So we cannot say, okay, will meet the x-axis. This curve will meet the x-axis at these 2 points here. Okay, so it is symmetric here about y-axis, about x-axis that we have talked about, not passing through the origin. And at 0, 0 point, 0, 0 origin, it is passing through the origin. And 3 and 0, the curve is meeting at 3 and 0 also. Okay, so what kind of this curve will be? Let me talk about that. 3, 0 and this. At this point, the curve is not passing through the origin. Okay, so let me draw that curve. So what kind of curve is this? But here y equal to 0, so 0, 0 is the point through which the curve is passing. So if I shift the origin to the point 3, 0, after that we will solve that. So let me shift the origin to 3, 0, then put the position. So shifting the origin to 3, 0, Okay, and putting this, solving this equation third, and rewriting, let me write, rewriting the equation 1, rewriting the equation third, we get, what do we get here? The point 30, we have to shift this equation. Let me shift this equation. It will be 9y square as it is, but here it will be x plus 3, and here it is x square only. So it's 3 minus x minus 3, 3 cancel out, it will be x square only, because it will be minus x square, that means positive square, x square only. So 9y square equal to this, equating the smallest degree term of this. For the smallest degree term, it's x square into x. Okay, and this is y square, this is x cube, and this is 3x square. So it will be 9y square minus 3x square equal to 0. This is equating the smallest degree term. The smallest degree term of this equation. So we get here 3y square minus x square equal to 0, or y equal to 1 upon under root 3x. That means y equal to 1 upon or x upon root 3 plus minus. It means here the slope is, tangent is, this is the equation of the tangent here. This equation of tangent. This is the equation of the tangent here. Equation of the tangent. Therefore, y equal to plus minus 1 upon root 3. That means m equal to the slope is, the equation of a tangent line is y equal to mx plus c. This is m into x plus minus 1 upon root 3, which is m equal to tangent of theta. That means tan theta here is 1 upon root 3. That means tan 30 degree, tan pi by 6 plus minus pi by 6 here. Because it is 1 upon root 3. 1 upon root 3 is for, so theta equal to plus minus pi by 6. Okay, so at this point, the tangent is having slope at this point 30 degree. Tangents are at 30 degree angle. So let me draw the curve. The curve will be of this kind. Okay, at the point 30, okay, the curve is passing through the origin we have, and at this point here, the tangent is making angle 30 degree. This is a 30 degree angle positive. Theta is equal to 30 degree or pi by 6. You may say t equal to pi by 6 here. And this is angle 30 degree pi by 6. Okay, so this is degree, and this is minus pi by 6, or this is plus pi by 6 here. Okay, so this angle is pi by 6. So tangents are making angle. This is the tangent here. Tangent at these two curves. Okay, these are the tangents here, this tangent and this tangent. So these tangents are making angle minus 30 degree and plus 30 degree with axis of x. So there are no what you call asymptotes here, because only these two tangents are there. The two tangents are making angle minus 30 degree or plus 30 degree. Okay, so these tangent, this tangent and this tangent. Okay, so this is the required equation of the, this is cusp type of equation. Why? Because their y square equal to 0, because this is smallest degree term, if I equal to y square equal to 0, y equal to 0, 0. That means this is the cusp type of coincidental tangents are there. In that situation, if I equate this equation directly, okay, so that means y square equal to 0, and from that equation also we will find out the sum points. Okay, so this equation is that point 1 upon root 3 we have obtained already, y equal to plus minus. So that is how This is the cusp here. This is y-axis, y dash axis, x dash, and origin O. So the curve is passing through the origin, we just found out, and passing through the point 30. This is only the point. And on x-axis, okay, the symmetric, because y square is even number, so by this symmetric to the x-axis we have described already, passing through the origin here because no constant term, independent term, so it's passing through the origin. This is the curve, and at this point 30, the curve is this 30 degree. So tangent is making angle 30 degree with the axis of x at this point. There's no asymptotes here. Why no asymptote? Because infinity is not, y is not tending to infinity. Okay, at point x equal to 0 or any point. So this is no asymptotes here. No asymptotes, and these are the two tangents which are made at this point. Okay, I'm making angle 30 degree minus 30 degree on both these sides. So this is the question number 8 here. Okay, so question 8 we have done. Now this equation is okay, Cartesian form. This is cusp type of question here. 8th question we have done here. Question number 8. Okay, trace the curve this x equal to t square. Now let me take the 9th question here. What is the 9th question say? Okay, so question number 9th now. 9th question says, 9th is trace the curve x equal to 80 square and y is equal to, what is that? Y is 80. Now it says it is parabola. Simple. Now let me again elimination method. So using the elimination method, the first method. So solution using the first method. Using the first method, that is the elimination method. The elimination of parameter. That is elimination of parameter method. This is elimination of parameter method, first method. Here also we have to apply the same. What is that? If I square this equation, okay, so y square equal to, let me find out. So squaring second equation. You say let me take second and this is the first one. Squaring second equation, we get, so y square equal to, squaring both sides, this is 4a square into t square. Now if I substitute t square value from first equation, okay, so putting value of t square from first into, this is third one, in third. So we get, what do we get here? This is 4a square into t square means x upon a. This is t square is equal to, from first equation, x upon a. X upon a is t square value. So in place of t square we have substituted x upon a. So 1a is cancelled out. So this is nothing but 4a into x, y square equal to, now this is parabola, standard equation of parabola. This is the standard equation or one of the standard equation of the parabola. Okay, so this is one of the standard equations of the parabola. So it means, now let me describe this, or simply we can okay, find out this, or we can trace this formula very easily, but let me describe this so that one can describe easily. This is just for the student to suggest that how to describe this equation by the same method which we have used in case of tracing of the Cartesian equations. Okay, so Same method is applied here, where y square equal to 4ax is the Cartesian equation. Is the now Cartesian equation of the parabola. So how will you describe this? Now here we have y square or even power. Y is the even power. So the curve will be symmetric to x-axis. The curve will be symmetric about x-axis. One thing, it will pass through the origin. Second point. Why? Because there is no independent constant term. Both the terms are having variables. It will pass through the origin. It will pass through the origin. Through the origin. As there is no independent constant term. Putting y equal to 0, x equal to 0. So origin is x 0 0. Okay. So and then we can put value of x and find value of y. We will plus minus value of y. So we can explain that simply. Here we get y equal to 0, or putting y equal to 0. Putting y equal to 0. Now if I put x negative values, then y is going to be negative. So x cannot be negative or less than 1, because we cannot go beyond 0. I mean on the negative side of x-axis. Putting y equal to 0, x equal to 0. So 0 0. The curve will meet the x-axis at 0 0, or both the axes at 0 0. So 0 0 is the only meeting point. Is the only meeting point of the curve on the axis. Both the axes, the curve will meet on the origin only. No other points is meeting point. So this is x 0 0 point. Okay. Secondly, if I put x negative value, y square will be negative. And if x is less than 0, negative value. Okay, or x is negative, y square will be negative.